Welcome people. Today we are going to try something very different. I was talking to a friend of mine who's an artist, and we were discussing how we can actually create art out of data. Now I've been a freelance designer, I like designing from time to time. So I decided, why not give it a try? Okay. So the first thing that we need to do is we need to prepare, get a good data set. So we can start with what we're going to do is we are going to first visualize something in Python and then try to code that up using Adobe Illustrator scripts. Something, different. So let's do this thing. Alright. Oh man, it's chilly, man. So this thing is stuck. What I'm going to do is that I already have some data sets opened up with me. So for Kaggle I actually need to register. So let's just go here and do that now. Now I did look into a couple of data sets. One is a global terrorism data set, probably won't do that. It's an interesting data set, but we like a data set that has a better visualization of things. So the distribution here you can see is pretty skewed per se. And there's one with Google, the Goodread books. So the thing that we can do here is you have titles, then you have the code, number of pages, ratings, etc., etc. Again, it's a super skewed data set. I mean, you can see between 0 to 332 there are 6,000 books or something. We need a data set that is multivariate. I did find something from this Russian thing, which is basically what you can say is you have this. Let me just open Google Translate. Let's see what it says about it. Okay, we have something now. The data set is dedicated to the data of some telecom operator. The dataset consists of 3,333 unique rows, 21 columns, and addresses the problem outflow of customers of the telephone operator. So you have the state, account length, area code, phone number, not really needed, international plan, voicemail, blah 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 blah. So what we're going to do is we're going to start with this particular dataset, visualize this thing in Python first, and then we are going to try to code that up using JavaScript script from Adobe Illustrator. Alright, so we're going to go to designs. Let's just call it data art. No, we're going to call it dviz. Alright, dviz. You have the archive file. Now we're going to open it up. I already have the Illustrator etc. loaded on my system, so we can start with this thing. So not streams, you have dviz, you open this archive up, you have the churn thing, and we are going to need a Jupyter notebook. We are going to be working on this thing. So you can just do cd dviz, and finally Jupyter notebook. Cool. And I'm going to take this thing down here. I don't want people looking at my private stuff. Close a lot of browsers and ease up our memory a little bit. Close a couple of softwares. WhatsApp, Sketch. No, I don't really need Sketch. Messages is fine. Postigo should be quit. I haven't used Postigo in a while now. Okay. No. Alright. So new Python 3 into this is churn pred. import pandas. No, let's just import csv dot, what do we have, reader. Yeah, I give it the file path, which is dot slash archive dot, no, not archive. You have telecom churn dot csv. No, man, let's just do it a simpler way. I don't want to spend time working on these things today. pt df is equal to pd dot read csv, and df dot sample 10. It gives us all these things. Now we are going to import matplotlib. Import matplotlib dot pyplot as plt matplotlib inline. Okay, so from this dataset thing, we can actually just, oh yeah, I'll open this. Now what I have is the total day minutes, total duration of conversations during the day, total number of calls during the day, total day charge. So what we can plan is something like what is the account length. So with data analysis, our objective is to use 3 separate variables and project them on our data set. So the first variable that we're going to use is probably total day minutes. Yeah, total day minutes. Our second variable is going to be the account length, and the third variable that, so on X you have the account length, maybe on Y you're going to have total day minutes, total day calls. No, you can also have total number of minutes. So these variables are going to be pretty similar. I really don't want to use them. And account length, and your state code is going to be your color. So you're going to have, yeah, so you have df.state state data is equal to values. Somehow I really don't like using this thing, what you call as the pandas. I just like using numpy, as it's so much more easier. You have even more columns. Let's just maximize this view, and we're going to say select all, apply. On Kaggle, the good thing is that you do get some very beautiful curves out of the case. Sign of customer outflow binary variables: true, false. Customer service, total international charge, international minute, total night charge. No, let's just go with total day minutes. Okay, so I have df total day minutes. Perfect. Values plt dot you have mins as this, plt dot plot mins. Okay, what you can do instead is we can use histograms, and we're going to say bins is equal to 50. Let's just return this. Okay, so you have pretty decent visualization. That's a good normal distribution. How many unique states do we have? Len set state. So you can have 51 different colors. We can do that. Yeah, we can do that. And finally on x-axis we should add account length. So we have account length, AC length is equal to df dot account length dot values and you're going to have the same thing here. Okay, now what we need to do is we need to create a plot, a scatter plot, where the x-axis values are AC len and y-axis values are the minutes. It's not really needed. You can also have this thing as binary for color. You can probably do that as well. We'll play with it. So plt.scatter x is AC len, y is mins. Yeah, it's not really interesting. For color, what do I have for color? Marker color, possible values, a sequence of n numbers mapped to color using CMap, a norm 2D array in which the rows are RGBA, a sequence of colors length n, single color format string. Nah, we need something a bit better than this. Can you use churn? plt churn value is df churn dot values, and for this thing what we are going to do is, let's just see what churn is. False, false, false. So we are going to say call is, yeah, color is either it's a RGB, so 0.0.255, or we can say 255.0.0. This is going to be a color churn calls, which is the color for each churn is call int x for x in churn. S must be a scalar. Yeah, so this is this thing. RGBA values should be within range 0 and 1. Okay, so that's fine. Just make this thing as 1 and this thing as 1. Okay. plt dot figure fig size is equal to 10 cross 10. Okay, is this a good graph to actually visualize? I don't think so. So what I'm actually trying to do is that you have two different normal Gaussian methods. When you combine two different Gaussian methods, you see something like this happening. So on x-axis here the account length. So those who actually, roughly you can say, those who talk too much have higher churn. False. Sorry. Yeah, you're going to have something like false and true. Alright, what else? What other variables do we have? Total night calls, total night minutes, total duration of the conversation at night. So you can also have, this is useless, total night, you know what n means. This is tf total night minutes. Okay. Again, not really useful. Nah, this is not a really interesting graph. Total evening, total number of calls in the evening, total evening minutes. We need to find correlation between some values and something else. Well, I don't think this is a good data set. Hmm, hmm, hmm. What else? What else good data sets do we have? The other one that we have is one on global terrorism database. I don't think YouTube is going to like that. I have one for good read books. Mm, yeah, let's see. I mean, so the color variable has to be categorical, because too many categories would basically make it a gradient. It does not look good. Internet news, customer card credits, undesirable events and oil wells. I have one about Indian food. I don't know how useful that is. So yeah, it's this one, which is Indian cuisine consists of variety of, yeah, most of people know that. Flavor profile. Presence in any one of them -1 indicates there's no value for it. This is a good data set if you want to use a web app for visualization. We're not going to be doing that. So the reason why I say if you have a lot of colors, web apps look good, is because then I can just go over one of them and a small hover pop-up actually gives me more information about that thing. It does not work with fixed datasets. Solar power generation. What do we have? Ultimate UFC dataset. B or RAS. Can use Iris. Should we just do an Iris one? It's so boring. What do we have? Plant ID. You have DC power, AC power, total yield. What's the X value? What's the Y value? No. God. No, we don't want to do anything else with COVID as well. Breast cancer, Wisconsin diagnostic dataset. Highly rated children books and stories. Movies dataset. What do you have on those? 228 MB file. No, man, I'm not going to do that. Hotel booking demand, data science cheat sheets, Stack Overflow data. It's a big query thing. Again, you can't really use text. I mean, we can in a way use text. What we can do is, if you have a text data set, you can simply pass it through a BERT and it would give you an embedding, and based on all those embeddings you can like get a similarity value. But let's not do that. It's boring. Brazilian e-commerce public data set. Chicago taxi trips. I used this one. Telco customer churn. Not really interesting. This IPL dataset. Is there something interesting in IPL? I hate sports. Maybe that's why I'm fat, but let it be. Let it be. World Bank education dataset. So data.gov.in for some reason is not opening. Otherwise, we would have used those. I would really like to see the government using the government data. I think that would be super interesting. New York Stock Exchange. You can have like beautiful graphs of how each company, the share price of each company moves. Netflix price data, anime recommendations dataset, world university rankings, Keras pre-trained, top 50 Spotify songs 2019. What do we have? I think it's just 50 things. Genre. Valence. Higher the value, the more positive the mood of the song. Liveliness. Ooh, this sounds interesting. We can try something with this. Archive 1. Go here. We do unzip this. Top 50.csv people. Let's do something. Df is equal to pd.read csv. You have top 50.csv. Oh yeah, what is it? Sorry. Top 50.csv, df.sample 10. Yay! There must be some Latin shit here. Oh yeah, see, señorita. It's literally the first line. Don't do that. Don't do that. I don't want to open pages numbers, man. What we can do is we can pass it. There has to be some encoding here. Encoding, yeah. You can actually pass it. Encoding is equal to Latin. Oh, so it is in Latin. Oh, see, it works. Nice. Alright, what do we have? What is the df.shape? Print df.shape. Yeah, 50 tracks, 14 columns, popularities, pitchiness, acousticness, liveliness, beats per minute. Yeah, so what we can do is the beats per minute, it can be like in a beautiful gradient. And genre. So how many genres do you have? You have df genre. Oh, capital G. You have a list set dot unique. Oh, dude, you have to do this. Okay. You have 1, 2, 3 R&B Spaniel boy band. Can you actually get a larger data set? It would be much more fun. Spotify songs data set. Spotify data set. 160,000 songs. Yeah, it's a 16 MB file. Artist. Danceability. Duration. Energy, explicit IT. Yeah, just select all, apply. Data by artists. You have, so the primary column is binary value representing the starts with a major or minor chord. Artist. Data by genre. Yeah, we can probably use this one. Is 34% of the dataset is nothing. Genre is not fixed, it's a list. We can't do that. Can't really use this. Data by ear. Yeah, we can probably do data by ear. So ear can be like your variable thing. Now again, people, I don't exactly know what I'm doing here. We're just playing around. Yeah, again, data by ear. So you have mode ear. What's the size of this thing? Can I get the size of this thing? Apply. Where did you get this data? Using Spotify API. Okay, never mind. Yeah, the key, the popularity of the country. Song default country is US. Well, congratulations, US. Yeah, let's try our hand with this. Oh, data by genres. What's the genre? Abstract, asset. Now we're talking, people. Now we're talking. Now we can use this thing. This is good. Data by genres. Cool. Yeah. Let's do this. How many genres are there? You have 2793 genre. What we can do is we can create a counter and see what are the most popular ones. From collections, import counter. To counter, you can give CNT is genres dot values, and with CNT dot most common top 100. Oh, we need to do it the other way around. What? Wait a minute. All these come only once? No, you can't do that. Oh, yes, spelling mistakes. No. So annoying. Right away, artist, count. Yeah, you can't do this in a way. Yeah, let's use this. It's going to take its time to download though. It's unfortunate. So what you can do is we can like see over the years how the explicit you can see like how many explicit things are coming out. So you have 19 columns, so select all, apply. It also has the tempo, the speechiness. You have the release dates. We can just use year for that, year of release, and you can check the energy of that music, the key of that music. Data.csv, what a beautiful name. Such a generic shit. How is one even supposed to understand what is happening? Okay, so you have data.year. On x-axis, what you're going to do is you're going to do plt.scatter. On x-axis you have data.year. On y-axis you can include data.energy. df. Yeah, you can't really make sense out of it. Okay, so we need to sort this thing, which is df.sort pd.sorted df.sort. Is there something like this? Apparently there is not. pd.sort. There's something. Come on, man. Come on. I know you're hiding in there. Pandas attribute has been sorted. So it says df.sort. Is there sort pandas. Oh, there is something called df.sort. You liar. df.sort. Sort values. Okay. By is equal to here. You have df is equal to this thing, and no, it does not learn anything. Ascending is equal to true. In place is equal to false. Let's just make it in place is equal to true. It's not doing anything. Do this again, I'm going to get a pretty useless graph. Also, I mean, like web, these things like d3.js, they're so much cool. You can actually create very beautiful graphs. What do you call it? Not exactly graphs, but data visualizations out of it. Like visualization. There's a complete thing called creative coding. Interesting. Observable. Annotated stacked area. This is interesting. Probably we can also try this. I mean, if you're just going to do data driven visualizations, we can use this product interactive dashboards. Oh my god, that's so painful. I don't want to do so many things with it. Oh no, let's not go there. We need to sort values. Okay, so the first thing we're going to do is, see, this is why I hate pandas. Instead I can just do this. Year is equal to df dot year and dot values and the correct idx. So what is this thing? Idx array. Okay, so it is an array. Sort by values. df is equal to this maybe. Sample. Oh, my bad. We should have done that. Oh, sorry. Is that it actually sorted by default? Oh, I'm so stupid. Data is already sorted. So clearly this is not correct because speechiness, tempo. Is it true that old songs are much better at speechiness? Or what is this? Are we getting somewhere? I think so. And what you can do is you can let's just make this thing larger. plt dot figure fig size is equal to 20 cross 10. See, now the ears are actually coming out of it. Cool. C is equal to df dot tempo. And you can just do plt dot color bar. Okay, now we're going to start seeing something. What is this? What am I looking at? I have no idea. Somewhere around 1950s, the speechiness of songs was suddenly high. Maybe that can actually happen. Oh yeah. Key. If I do key, what happens then? You can actually start to no. Energy. Let's just put energy here. Again, I have no idea what it's talking about. is acousticness related to your speechiness? So acousticness was no. So let's just for clarity, plt.x label is time in years, plt.y label is acousticness. You can't understand anything out of this thing. It's basically what it's saying is the since like 1960s we fucked up where the acoustic before 1960s the acousticness was, so it is doing a scatter plot, but it can also be a histogram. Can it be? Can it be? It should be. Is it? No, it is not. Loudness. How much has loudness changed in years? So acoustic music has become louder and louder. Is that what it's saying? So, oh wait. So this means that more acoustic the song is, the less acoustic the song is, the louder is. Oh, see, we're getting somewhere. You can also start like drawing lines from it. We can try that. This is such a beautiful visualization already. Explicit. Yeah. Was there bad words in there? Yeah, so older songs were like extremely explicit before 1960. So for some years most of the songs are explicit, and the explicitness of song has also been increasing in recent years. Cool. What we can do is we need to aggregate data based on years, so we can actually start drawing lines. So this kind of scatter plot is not really useful. What we can do is we can like add mean values. Yeah, let's add mean values. So df 1920 is equal to df dot year. So df dot year is equal to 1920 dot, yeah, oh wait, what? Oh yeah, 1921. Okay, cool. The duration of songs. Has the duration of songs actually increased in recent years? Acousticness. No, it's still duration. It's still duration, mate. 26 milliseconds. So the songs have consistently stayed like this at the same volume, same length. What we need to do is we need to like aggregate data in different terms. Man, I hate doing EDA. Why can't I just ask it questions? Right, and it would just convert that natural language thing to code or pandas thing. I did start a project based on that. It's called text to SQL. So what you do is you can ask it questions in natural language. Yeah. Now this is a simple artwork. What is it? So you can just ask it questions like, what is the name of every student who has a dog but does not have a cat, and it takes this particular natural language question and it combines with your database schema and is supposed to create a good SQL out of it that can be run. Right now it's not working very well, so you get this stupid shit. But yeah, let's see. Anyways, coming back to this, what we need is, for every year I can just start searching things like, for every year what was the mean acousticness, acoustics, man. Multiply sequence mean. Oh, see, it works. And then what you can do is we can just run this thing in a loop for, so AC is the list of all the acousticness for year, goes from this thing to to 2020. So for year in range 1921 to 2021, for the range of these 100 years, we have df2 is equal to df dot year is equal to year, and what we can do is ac dot append df2 dot acousticness dot mean. Yeah, we're getting somewhere. And you can just do plt dot plot ac. So this is interesting. The acousticness of songs has been decreasing over the years. See, now we're getting somewhere. So now what we can do is we can like feed it all these values and run another loop on top of this thing. So you have something like means for k in danceability, acousticness, valence. Oh, where is it? Yeah, acousticness, valence. Spelling is correct? No, it's, yeah, valence, danceability, energy, man. We need the goddamn energy. Energy. You have instrumentalness, and you have the liveness. What does liveness even mean? But whatever. And you have loudness, popularity, not exactly sure what that means. You have speechiness, but well, what we are doing wrong, man. I should live stream. Yeah, means here AC, whatever, means K is equal to AC K. Alright, cool. For K comma V in means dot items, we first define plt is equal to plt dot figure fig size is equal to 10 cross 10, no, 20 cross 10, plt dot plot v, and the label is equal to k, and you do plt, oh, not this k, it's this k, plt dot legend. Okay, so is there anything here? No, because there is not anything in here. If we remove the tempo, which is a super high value, and we remove the instrumental, we can do a mean of all of them. So we can remove the tempo, and we can remove the loudness. I think this is loudness, right? Okay, so the speechiness of songs. Now this is a mean, which means that even if these songs actually increased, uh, it stays pretty consistent. So what is this? Energy. So the energy of songs has been consistently increasing, danceability has been decreasing, the acousticness has been reducing, the liveliness has been pretty much consistent, and speechiness is completely fogged up. Instrumentalness also has been decreasing. You know what? This is it. This is our data set. This is so not our database. This is what we're going to do. plt.x ticks, which is, we need to give it ticks. Ticks is equal to range len v, and labels is equal to this thing, x for x in this thing. Oh wait, what x? Or ticks. Now it's gonna work. Ticks, rotation, not 50 asshole. Rotation is equal to 90. Yeah, it's going to work. Cool, mate, cool. So you know what we're going to do? We're going to take this thing and we are going to plot things out of it. And what else we can do is take the loudness and we can say if k is equal to loudness slash tempo, we need to normalize it, and our normalization is going to be super simple. Instead of just making it AC, we'll make it an numpy array. From numpy import numpy as np, and you have this thing which is np.array, and means k is minus means k dot max, no, means k dot min, it's going to be, yeah, and divided by means k dot max minus means k dot min. Was it normalized? I think it did something wrong. No, it was right. Loudness has also been increasing, tempo has always been increasing. Now we know that because tempo is very related to the danceability of things. Okay, so this is our data set. This is what we are going to visualize in PL. Let's just make this thing even fancier. Title, properties of songs over past 100 years. Nice. And we can also give it an x label, y label. plt.x label is years, and plt.y label is it's the value. Let's just call it value. Now we can in a way change text. What we can do is we can just say it's starting from 0 to we can skip 10 years, we can skip 5 years, and we can do 5 years as well. Yeah, now it's far better. 26. Yeah, if we do 4, we might actually be able to cover all of them. Alright, cool. and you can just remove the rotation, and this is what you have. A 5, and 5 makes much more sense. It's easier for people to understand what happens in 5 years. Okay, now we have our target. What we're going to do is we're going to import this thing here. That's right. This is our matplotlib thing, and we are going to convert it into a very beautiful object in Adobe Illustrator. Chart. Let's just call it Spotify mean values chart. Oh, cool. Now we are going to do probably the difficult piece, which is how to actually work with how to use this thing. What do you call it? The scripting, JavaScript scripting. But before that, we are going to take a very small break. I'll be right back. Maybe I'll just zoom it in, so if the 3 of you, those who are watching this thing, want to study a little bit better, go enjoy, people, enjoy. Alright, I'll be right back. Okay, let's just look at it a little bit. So green is valence. What does valence exactly mean? What do you mean by valence? Valence in music. Positive. Oh, these are so beautiful. Where is it? That is such a beautiful graphic, man. Shape of you. Other people have been doing it as well. But see, you're making it in whatever this is, most likely matplotlib, and we are going to make it in Illustrator. Make a goddamn art piece out of it. Visualizing my music taste using machine learning and sentiment analysis. It's too much of an effort, man. Keeping your own thing together. See, the instrumentalness and the speechiness, these are hyper skewed things. These are called power laws. I mean, if I say what is the mean instrumentalness of your music taste, that's not really, that doesn't mean anything. It's so skewed, that's stupid. Why we are doing it? It's because we can, even if it is stupid. Do clustering, mate. Do image clustering, song clustering, or whatever. Still sell stupid shit to people. Make yourself sound smart, and you're actually doing something that is very stupid. So simple. I mean, even this work, it's so simple. I don't know why people don't do it. Okay, so let's start. What we need is, should I open code or Sublime Text? I'll open code. I'll open from here. Now we are going to create Spotify.jsx. You need a .jsx file, and your JSX works something like this. Alright, so text on path. No, I don't need text on path. Trees.jsx. Yeah, this thing is much better. So what I'll show you how what running this thing does. So I have scripts. From scripts I can open this up. Other script. So I can add trees. It's going to create a new document, and this is what it does. At its core, this thing, I think this is a good start for us. What it does is that you can define, I want to make 50 trees from this thing. So because this thing has a it's basically, it starts from a for loop directly. It's the main function itself. So that is why I think when you do create this thing, it creates, anyways, I'm not sure, but whatever. You create a pyref, which is all the path items. It's basically the list that is going to carry all these path items. You have docref, that is the document. It's not being used anywhere, but whatever. So for 50 trees, you create a path ref. You tell it what is the path, set entire path, and you basically create a giant array out of it. Now move trees to a random position. So left, top, all these come from random values, and path ref dot position is left top. Scale, again you give it a random scale. Stroked, you set it as false. If you set this thing as true, this is what you would get. And what you can do is you can say, I want just 20 trees. You know what? And what you can do is you can say 20, and what else was I going to do? I forgot. You know what? Oh yeah, path ref stroked is equal to true. So I can just close this thing. Don't save, mate. Don't bother saving. Scripts, other script. I go to designs. I can then go to divs, Spotify.js, and see, it's so beautiful. You get stroked lines and shit. But see this. Now what is happening is that it's not an entire path. What exactly? Oh, this is new. This is my assumption. What is happening, if I just pass it both the front and the last ones, now it is going to work better. Yeah, if I do this, it's going to fix this issue, which is I can do this scripts, other script. I can go to Spotify.jsx, and then it is going to complete this thing. Still not joined, but what you can do is you can just go to stroke, make it a round thing, and yeah, either you make it a round thing or this thing, and it works. If I do it sharp, if I do it sharply, the edges become sharp, while the joints, or what you call as cap, they are still square. So corner is also a round joint. But this is a good start. So what we can do is we need to define all our data in all these arrays. So the first thing we are going to do is we are going to write, and because you have to write it in this format, it's super painful. So we are going to write a script to actually simply generate this data. Alright, so you have this, and you can just go to means. It's going to give you a pretty good thing. And so new array, what are the two values that need to be put in here? Again array, but here is the actual path. Okay, so array is going to be the XY coordinates of this particular value, but I just have Y. So let's just play with danceability. Dance people, dance. So what I can do is TRA is the target array for means danceability, for I in for I in G, should we just do 0 to 100? How many points do I have on the artboard? I have 841 points. So I'm going to take it to 600, which is for I in 0 to 600. And I'm going to say 6 TRA dot append I means, so I and X, and I can just do this, means I, for means danceability I. Append takes exactly, now X goes here. So my TRA, actually I'll just check the length, it's 100. Okay, cool. So I have this as my TRA, which is something, and I need to convert it to this beautiful text object. So for X comma Y in TRA, print new array. We're just going to, let's just do it the fun way, which is the easier way. X point 0.1f, at least I get a floating point to 0 point this thing. I hope it does not throw an error like that. And I have Y, and it ends with a comma. Alright, so I have this entire thing. Alright, cool mate, cool. I have this thing, and then what I can do is var pathref is equal to pyref dot add, and we are going to add for this thing, danceability. And pathref dot set entire set entire path, and the set entire path is going to be a new array, or what is this new array, and this object is going to be what I copy paste here. Now the the pathref.stroked is equal to true, and pathref.filled is equal to false. I don't want it filled. I want it to be my outline, and it's probably going to be a stroke color, but we'll skip it for now. What you're going to say is you have this thing, and let's go. Don't save. I have scripts. I go to other script. I can open Spotify.jsx, and no, it's not showing anything. Okay, what am I missing? Pyref.create. I have added this thing. I have pathref. I do set the entire path. Once I've set the entire path, I need to give it the position. Oh, okay. So this is the design of it. I think so. Position, and all I'm going to say is it has to start at 10, 10. Don't save. Go here, scripts, other script, modify.jsx. Oh, here it is. Oh shit. So what has happened is, oh, okay. Now this value needs to be multiplied by 600. Yeah, now you're going to start seeing some values. Is you define this. Is there some way I can just load this thing from somewhere? Probably. Did add it. It's my mistake. I didn't find it. Spotify.jsx. Open this thing and see, you get some beautiful lines. These are the best lines you'll ever find. The best lines. Oh, interesting. Now that's it. That's it, folks. That's it for the stream. No, I'm kidding. But now the rest of the process is just designing it, which is what you're going to do is we're going to go over each of them. For k comma v in means, oh, not k comma v, it's items print and then what you're going to do is you're going to do this, and we're going to do this, and we're going to do this. So this way I can get a pretty decent. Should I write it like this, or what I can do is, for simplicity, I can just make it like this. Print space dot join. Yeah, now it's much more easier. Now all I have to do is, I also need to put in copy paste, which is I need to print what this thing is. So right now I need to print what k is. Danceability. Yeah. So we first defined as danceability. Position is 10, 10. Yeah. Because we'll need to lock them up all in group. If we give it a fixed position, we'll need to lock them up all in certain groups. How do I figure out which one is which? There's like two processes. One is manual, other is completely digital. I can add yeah, you know what, let's just do it manually, that's fine. And so all I have to do is I need to add this shit for all the others. Cool. So I have done danceability. The next one is acousticness. And this thing is acousticness. I'll probably have to verify manually what all these different ones are. Okay, this is valence. You have energy. Yeah, mate, energy, mate. Do you have the energy? I think we have the energy. I don't have the energy. Energy. And I have the instrumentalness. And I have the liveness. Shit, man, I'll have to do this thing manually. Liveness. And I have loudness. And I have speechiness. What does speechiness even mean? I don't care. It is. We live in a post-irony world, mates. Speechiness. Comrades, mates, whatever. Communism is back in the cool thing. I don't think I'm studying. Okay, cool. So on save, we go here, we export, sorry, scripts, other script, Spotify.jsx. Oh shit. All of them are the same arrays. Hush, 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 hush. No, but all of them are the same arrays. I fucked up somewhere. Ah, it's all means danceability. Oh, kill me. God damn it. You know what? You know what? You know what? Fuck you. Yeah, really. Fuck you. We are going to say TR is this thing. And we're going to just code this entire thing up, man. All I'm going to do is I'm going to define print. No, let this be TR2. This thing. And we are going to put our TR here. I'm going to finally end with this thing. F print TR2. It's like so much easier. Danceability, acousticness, no valence. Okay, cool. Acousticness. But shouldn't I have yeah, it also needs this piece, which is pyref.add. It needs this because it's a script and it uses the old school method. I do this and I do this. So I have valence set Now I'm going to use the energy, because why? I don't have the energy. We live in a post. I don't know how many of you have heard listen to GTA music, like when you're actually working or something. No, wait. This thing is this thing, and this thing is, yeah, cool. Liveness is now just this thing. And then you have loudness, which is this thing. And you have the speechiness, which is this thing. And you also have the tempo. I think we missed tempo last time. Speechiness, yeah, no. See, we did it correctly. Which is this thing. Cool. Don't save. We're going to run this script again. Hopefully this time we haven't messed up. No, we have not. However, the values are complete shit, but you can just scale them up like this. I'm going to group this just for the sake of this particular thing. Okay. Is this right? Is this wrong? I don't think that grouping them was such a good decision. In all of these cases, we wanted to start at a particular location. Let's just see. Let's just compare it with this thing. Yep. I think we messed up somewhere. You know what? We can next time, once we figure this out, we'll probably just let's just put this thing as the starting point. So the first point for all these arrays is going to be the start point of their actual value. And then you have this thing goes here. We go this thing goes here. You have this thing, it goes here, and you have this thing and it goes here. And for now, let's just comment all these. And to save it, we're going to delete this thing again. Don't save. We're going to scripts, other script, and again run this project. Okay, so apparently if I do this, it's not going to be correct. Sorry, if I do this, this is not correct, because what we have done is we have essentially squashed all of these. No. Adobe Illustrator, all these files Adobe Illustrator align script. I think this is like the limit of my brain power. So you have position starts at this thing, which means that what these values are doing is, so we are telling all these values to start at one particular object on one particular coordinate, which is 10 cross 10, 10 comma 10. And then what happens is, for now we are also going to like comment out this much. Cool. What happens when I do 10 comma, what exactly is happening if I do a 10 comma 10? Scripts, other script, Spotify.jsx. Okay, what is happening here is that if I tell it that it has to start from one particular location, then what are the three values that we are doing right now? It's danceability, acousticness, and valence. So danceability is the blue one, which is what this thing. The acousticness is orange, which is going down, and valence is actually going up, but the absolute value of all these things is 0. One way to bypass it is I can tell it that at the start all these values have to start from a fixed location. Yeah, let's try that. New array. If I tell them that all of them have to start from one location, maybe they behave better. And we can like probably crop them right from here. Now again, this is cheating because we want our entire code base to behave the same way. Okay. Okay. Now it's a bit better because it's at least because you told it that it should start from the same point. It's doing that. Otherwise what it does is, oh, now I get what it is doing. So because I'm telling it that it has to start from a point called 10 comma 10, what it is going to do is it's going to assume that whatever starting point that you gave it is actually 10 comma 10. So this is in a way cheating, but in a way it is not, because path position, can we delete path ref? There's another documentation, Illustrator scripting, which is, yeah, read the docs. Can't believe that read the docs actually even other ones use read the docs. What I've done is I have active document.path items, and so this is my path items, and so I have a path path item dot area dot artwork knockout, blending mode, clipping. No, this is not it. Path items. Okay, path items dot add creates a new object, returns a path item. Okay, so what I have this path item. What I can do is fill over print, geometric bounds, guides, height, hidden, layer, left, length, length of this, no, logged name, note. Yeah, I just said its name, but let be parent, path points, pixel line, polarity, position. We are giving it a starting position. If I don't give it any position, what happens then? If I don't give it any position whatsoever, then it should generate something. It should assume that all these values are correct. Is this correct? So you have this value, which is acousticness. It's continuously going down. You have the energy, which increases, and you have the danceability, which also increases. Oh, so in all of these cases we actually don't need to give it any path positions, and we are set. Oh shit. Okay, I have this thing. I select don't save. I create script, other script, Spotify.jsx, and I open this. Damn boy, damn boy. I can just delete this. Creates a group out of it, so all the boundings, scalings are locked, and then I can just do this. I think so. It should give me a better graph. Is this correct? Oh, I can visualize it using this thing, which is that if I overlay this on top of this, it should come up perfectly. And yeah, it does. Oh yes, good. We are on the right path, people, gentlemen. And now to create the artwork. Now this process, it's going to take some time. Why? Because I am a bit compulsive when it comes to these matters. The dark should be CMYK. I don't want it. Yeah, you know what? Let it be. So we're going to take these lines. For now, what we're going to do is we're going to color them as white, so we can actually see them. Okay. And we are going to put up some text, which is. We also need the ears, right? No, let's not put in ears. We'll put in like couple of ears in between, but not all of them. No, we're not going to do that. Okay, so we can put up text, which is, what do we call it? Spotify, song properties overpassed century. Why? Because people who are going to read designs are stupid people who like to not spend time reading numbers. Why? Because, well, they're stupid people. Maybe I have like such a few fonts installed. My system. Let it be this thing. Let it be this. Oh my god, no. Song properties over past century. And we probably change the properties, the strokes here. Make them all capped like this. It's much more smoother. If I do this and I do this, what looks better? This thing. Projecting cap, because it comes with the edge. So I have projecting cap, I have the cap, what is called butt cap, I have the round cap and projecting cap. Let's use the butt cap. The default is good enough. Okay. And finally, what we need is we need to put this thing. What are all the properties that we have set up? So we have danceability, acousticness, valence, energy. We have instrumentalness, liveliness, loudness, pitchiness, and tempo. And we are going to paste them here for our reference. Bold. This goes from bold to light, and it goes pretty small. Just like this. It's completely unreadable. Okay. No, not bold. Regular. So one thing we can do is we can like try to give this thing a gradient, but no, I'm not going to do that. Stream is already 1.5 as dance. Oh no, wait. This thing is here. It needs to get aligned to this point. Okay, makes sense. Danceability. Is my spelling correct? I don't know. Danceability, ability. Okay. Danceability, acoustics. You have the valence. I still don't know what valence actually means, but it's fine. Whatever. Energy. You have the instrumentalness. You have the loudness, and you have the pitchiness, and you have the tempo. Cool, mate. Cool. What you can do is we can probably make them all distribute it, and make them in the same row. Oh yeah, cool. Now we need a good color combination. So we're going to first decide on the colors of these things. We can probably just borrow them from here, but do you have a good butt? That's all that matters. Have a good butt. Is you're gonna have danceability, which can be. See, this is where I fuck up. Danceability, acousticness. I can't select good colors, mate. It needs to be good. Valence, bright purple, maybe. Who gives a shit? Bhagwa. And you have green. You need a good shade of green. Maybe this one. Maybe a little bit dark or saturated. Okay. And you need what else? How many colors? It's already done. You need a poppy red for loudness. Why? Because, well, it is loud, so I need loud color. Speechiness and speechiness and instrumentalness are super close. So instead, what is this? What is this color? It's a pretty awful color, but you know what? Fuck it. And you can have a yellow tempo. And you know what? Oh, we already have yellow. Let tempo be white. White is also a good enough color. And instead, what we're going to do is energy. We're going to change the color for energy to something that is a bit more strip club, which is pink. Okay, that's what I'm talking about. Danceability. Okay, now what is danceability? It's a blue one. They want to, so let's go one by one. No, we can't go one by one. So 1, 2, third from top. It is this color. Nice, mate, nice. Have acousticness, which is the actual orange, which is this color, and you can just put it, oh man, do this. Valence, which is this. Where is valence? It's the green one. If it's from the bottom, and you flip it, you have the energy is strip club pink, which is the top. Why? Because strip clubs, not that I have been to any, I would like to be, but I have not. Why? Because, well, in India, those are awful places. Oh, I think we messed up. Wait a minute, I think we messed up. Instrumentalness, this is the instrumentalness. Okay. So I have the instrumentalness. Instrumentalness is the gray one, sorry. This is instrumentalness. And boom, this is your instrumentalness. Your energy is the red one. Okay. This is your energy, and you have loudness. Oh, we did not do lightness. 1, 2, 3, 4, 5, 6, 7, 8. I think we missed the lightness, but you know what? Just let it be. It's too much effort now. So you have loudness. Loudness is the pink one, which is the upper one. This one. What I can do is I can just do this, and boom. And finally you have the speechiness. The tempo is white, so that's fine. Speechiness is the one that has second last. Okay. Which one are we missing? This is the tempo, and the one that drops is the instrument. It's the instrumentalness which drops. Okay. We have added liveness. Okay, no worries. This is going to be this thing, and let this be, just whatever. It's fine if it ain't nothing. Which is the liveness. No, not the Marathi. for liveness, this is the color that we're going to choose, which is this thing. Switch it to this, do this, no, do this, and boom. There you have it. Now you have 9. What we can actually do is we can spread them across certain divisions. Yeah, much better. Okay, if I do this, it's not going to give good results. Yeah, that's what I thought. So instead of that, we need a good measure. So if we convert it to objects and then say distribute equally, it still doesn't do that, because it's then going to take the weighted thing, which is stupid, but you know, okay, whatever. You know what? This looks super horrible. If I make it black, and what another thing that we need to do is we need to give it bleeding edge. What I mean by that is it needs to have a beautiful white edge running across it. And I can press option, and it's going to do this thing for all the edges. I can actually just this. What the hell? What? Yeah, much better. Yeah. And then what you can do is you can say this thing, artboard, the size is actually going to be 52 artwork pounds. Cool. Okay, cool. And this thing, I can just declare it as white. Happens medium. Should we give it a gradient? Why? Give it a better strip club feeling, mate. Don't you get it? The past century. Converted this thing to RGB. You have a value that goes like, you know, reddish maybe. And with black spectrum, you have something that goes white. Yeah, well, much better. And I can do an RGB, and you can just select the gradient that you want. Past century. Now you know what? I don't know, man. Can do this, and I can just do a very simple linear thing. And freeform. What is this? Points, lines. Here it is. Okay, if I do that, I need this red to be even darker, more pumpier. So let's green and let's blue. Song properties over a past century. That's it. take down just a little bit, and we're going to add our thing here, which is actually boundary. Yeah, that's it. That's it. That's it, people. That's it for this stream. I think it was a pretty fun project. It's a pretty cool project. Learned a lot, and yeah, I think that's it.